Hello, everyone, and thank you for joining our webinar. My name is Peyton Weston, and I'm a sales manager here at aPriori. Today, we'll uncover strategies for winning more business by driving a faster RFQ response time, promoting digital collaboration, and nurturing customer-supplier relationships. You won't want to miss Nick Rowland's case study on how Team Industries' aPriori implementation has drastically enhanced communication and collaboration with our customers and suppliers. Now, let me take a minute to introduce our speakers. Today, we have two professionals who will speak to you about strengthening partnerships by digitalizing your RFQ process using aPriori. We are joined by Steve Peck, VP of Application Engineering at aPriori, who started in the industry over 20 years ago and has made it his mission to deliver innovative engineering solutions that bring products to market faster and on budget. Also, Nick Rowland joins us from Bagley, Minnesota, as a strategic cost estimator at Team Industries. Nick has an expansive background in his over 20 years at Team as a machinist, programmer, manufacturing engineer, and program manager. He is best placed to recognize the importance of communication, collaboration, and transparency throughout the RFQ process in our digital world. First up, let's hear from Steve. Steve, take it away.
Great, thanks, Peyton. And good morning, good afternoon, everyone. So we're going to take a look today just at the RFQ process as it stands today and the traditional approach for responding to RFQs as a supplier. We'll then look at ways of digitizing the RFQ approach, bringing collaboration into the mix to really help bring the OEM and the supplier closer together. And then we'll move on and listen to Nick and his experience with Team Industries, and then we'll finally wrap up with some Q&A. So if we look at the RFQ process today, depending on your position, whether you're a build-to-print supplier or perhaps you have design-build responsibilities, there are lots of challenges associated with. But in general, an RFQ comes into a sales team where they need to start gathering the information necessary to build the estimate, working with estimating teams, working with sourcing teams, because some portion of that bid package may be outsourced to suppliers, and those supplier quotes need to be considered as well. There's collaboration with manufacturing to understand capabilities and further estimates and understand lead times. And finally, wrapping up with the response back to the customer where management pulls this all together. All of this takes a lot of time, a lot of resources and people in the mix, and a lot of data to be collected. Traditionally, we see that building the estimate and gathering all the information is done with some traditional tools, spreadsheets, looking at historical components and products that have been quoted to gather that information, looking at RFQs from outside operations, pulling information from internal systems. All of this adds some inconsistency in the estimate. I might have an estimating team of 10 or 15 people. Everybody will end up potentially with some variation. It's very, very labor intensive. And there are some challenges in terms of really responding in a timely manner with the confidence that you're pulling the right information together. And as a result, we end up with redundant efforts where there's potential for taking too long in missing business or overpricing to protect your margin, which ultimately can lead to missing an opportunity, or worst case, taking on business that you're not going to achieve the profit margins with. All right, so let's just talk a little bit about some of the difficulties with estimating and why there's opportunity for improvement here. So if we look at a should cost and the estimate that's provided, there's variability that gets built in, and there's a window, if you will, of uncertainty and a range for that estimate, and that's due to a variety of factors. It could be different estimators quoting the package, could be just the factors of leveraging historical data and the new part being different to some extent, or the complexity. So it leaves this band, if you will, of the range for an estimate. And there's a narrow window between pricing it and ending up in a situation where you're not profitable, or overpricing and not being competitive. So what we see with the traditional approach is there's variability there. So one in the estimate itself, and then the other in terms of where you fall relative to that window where you may potentially be too low and not profitable, such as these two out of this package of 7 parts here. You know, being on the bottom end means that you're going to potentially lose money on those. Whereas you really want to be in that middle band there where you're not overpricing and losing the business because somebody else is more competitive. So the reality is oftentimes many suppliers will err on the side of caution and go on the higher side in terms of their bids to make sure that the business they win, they'll actually achieve the margins with and won't lose any money on those. Worst case scenario is that you actually are on the other side, and hopefully this doesn't happen often, but you're underpricing and not really fully understanding what you're getting into and what your costs will be, and you're pricing your projects too low. You might be winning the business, but it's bad business. So how can this be addressed? One of the things that can be done is to increase the precision, reduce the variability between the different estimators, for example, and really narrow that band so that you can hone in on the right RFQ price. The next thing you can do is eliminate the variability and improve the consistency so that no matter who is doing the estimate, all of the manufacturing factors are being taken into consideration and the same results are generated from estimator to estimator. And lastly, we can put this in the range where we're pricing at a competitive price, yet achieving the margin. We know that we're going to make the expected margin because we're pricing it in the right range here. So ultimately, we can get into a situation where we're bidding very competitively against the others that are available. We're increasing our win rate because we're quicker. So if we employ a method of responding at a much greater speed, we can be first in and potentially win more business, especially with a competitive price, and make sure that we have a predictable and ultimately evolve the profit margin with competitive bid packages. So an approach to do this is what we'll review today, where we look at pulling information directly from the CAD models in the bid package to perform an estimate, understand the manufacturability requirements, and ultimately estimate the costs based on your digital factory and your operations and all of your factors that go into really pulling that together in a timely manner and understanding your digital factory, the capabilities that you have, your specific materials, machines, and rates can all be factored in. And doing so in a collaborative way. So making sure that everybody in the loop needs to be, has the visibility to the different pieces that go into the overall RFQ and can contribute and ensure that everybody is on the same page. And this extends out to the customers themselves as well. So at this point, let's launch a poll and look at what percentage of incoming RFQs you choose not to bid, whether due to time and effort, capabilities, or even capacity. Nick, do you, based on your experience with team, do you want to talk a little bit about jobs that you potentially pass on?
So every company, of course, does no-quote something. Typically, though, team vets our customers, and we develop deeper relationships with our customers. So by and large, if it's something that you need and you're a good customer, we try very, very hard to be a good supplier. So we'll give it our best shot to try to quote everything that you need. Some stuff we'll agree probably isn't a good fit, but we do our level best to provide solutions for you in every case.
And it looks like in many cases here, based on initial results, so in 50% of the cases, 5 to 20% are not responded to. So it's pretty interesting. So let's go ahead and move to taking a look at the solution. So we'll run through an example here where we can look at quickly responding to a bid package and also introducing capabilities for collaboration. All right, so I'm going to log in to a cloud-based solution. So the aPriori solution, which consists of a variety of role-based solutions to support the overall bidding process, manufacturing simulation, and costing effort. So we're going to start in aPriori Professional and take a look at this example of a TV mount. This is actually for a decent-sized 70-inch TV that a contract manufacturer is sending off to a supplier. So this was brought in directly from the NX CAD system, where the assembly is recognized, the hierarchy, all of the components have been identified. What we want to do is actually go through a process of very quickly estimating these parts. So we'll kick off an approach to bulk cost the components in this assembly. So we'll create we'll point to the directory where all of those CAD models live. This is going to be for the sheet metal components of this overall assembly. And we can see the directory that contains all the CAD models, as well as some details about annual volumes that are captured in a spreadsheet. So that is an automated approach to quickly process a whole host of components in an approach where it just simply runs in the background. And I'll actually kick that off, and we'll look at an interactive approach on a part-by-part basis to estimate a component. So we'll take a look at this clip at the top of the bracket. So its purpose is to allow for a 15-degree tilt of the bracket attached to the TV, and also to hang it initially from an installation standpoint. So it's just a small sheet metal component. We'll go ahead and open that up while the processing is happening in the background. First, this is a sheet metal component being manufactured at a digital factory in Suzhou, China. We have a variety of manufacturing processes that could be used to build this component. So in this case here, is it a laser cut and then bent? Is it done on the turret? I know that this one here, based on the volume, is going to run on a progressive die. And there's going to be 200,000 of these parts for 3 years. So the cost in manufacturing simulation is going to get kicked off in first understanding the geometry of the component, and then simulating the manufacturing process in each step along the way. So that takes a few seconds to complete, and we quickly return some results here. And this part here is a 63% fully burdened cost component with $17,000 worth of tooling. Looks like actually I have a pop-up here in the background that indicates that the other components in that directory have all completed their simulation. So we'll just dismiss that and take a look here for just a minute. So what's happened in the background is the manufacturing process has been simulated, and a progressive die with 6 stations has been chosen. That was determined based on a complete understanding of the geometry of the component. In this case here, how many bends in the component? There's 3 bends, some simple holes. That's all factored in to determine what it will take to make that part, each of those features, and essentially the operations happening at the die stations. So further investigation, we can see here that the material is actually taking up 80% of the cost of this component. We can see the utilization over on the right here of 43%. So we're throwing away over half of the material in this part. That was arrived at by estimating the strip of material and then nesting the components on there. As we can see, you know, it's the best you can get to align these components here, but still some material being thrown away. So with that said, let's just jump over back to the assembly. Now that everything's been processed in the background, we can see that those components that have been automatically estimated, we can see the cost associated with each of those, and the manufacturing simulation has been completed. We can even see the capital investment for the tooling on each of those components. So let's take a look at, the material utilization was in question there. That was pretty low on that part that we just did manually. We can take a look across all of the components we ran in a reporting environment to analyze at a higher level all of the information. So in this case here, we'll run a material utilization report on that set of parts to see if there are any other components where we might be able to investigate ways to more efficiently make those parts. And what we see is that most of the parts are well over 80% in terms of their utilization, which is great, except this one that we just went through manually is at 43%. So maybe there's a way of doing something to better optimize this material. So ultimately, we're throwing less away. So if we look at this component and its function, so it is serving those two purposes of hanging against the plate that goes against the wall and also allowing for this 15-degree tilt on the component. But if I look at it, maybe does that really need to be a separate part? It's actually being fastened with 2 screws on each side, and then also to the back plate, which requires some through holes for clearance of those screws. Maybe that function could be incorporated directly into this component here. So I can go and provide some potential options for the customer to have some value add rather than just taking what I'm giving, quoting it. Maybe there's an option to provide some DFM or some design options that could ultimately benefit both of us, improve the product. So I went through that process of a little bit of CAD work, and I consolidated those 2 parts into this revised version. So the feature to hang it is still preserved, as well as the ability to have that 15-degree tilt. I've gone from 2 components down to a single performing the same function. I've eliminated 4 fasteners per side on this. So let's take a look at the result. We can go ahead and update our costing result based on that change. So what we see here is that based on the revised approach, we have an updated cost on this. So originally, for the initial design, this was at $44.03 for the total cost, and that's summing up the individual components in the hardware of that entire assembly. In the revised version, we have a final cost on this of $41.99 for the total assembly. So it doesn't seem like a big difference, but it's actually $2 over 100,000 components annually for 3 years. So we're looking at $200,000 per year, well over $600,000 here, potential savings based on such a little change like this. This could now be communicated back to the customer. So I actually could attach some notes here and provide this feedback. Hey, if based on some material utilization concerns, we looked at a potential way to reduce part count, lower the overall cost, still maintain the function. Maybe it's something worth looking at. We have a potential of 204,000 savings. What do you think of that? So as a supplier, I can provide this added value, if you will. Now this could be shared via a report with the customer directly, or what we might be able to do is provide them access to directly log in to the cloud-based environment where they can see firsthand the changes that were made and interact with this with their supplier and really have transparency on cost and ultimately be able to understand and share the details of manufacturing. And in some cases, we have some manufacturers we work with that have gone fully open book and are simply agreeing on margin. So here we can review this entire assembly, can take a look at the notes that were shared from the supplier based on these potential changes, and ultimately dig into the details of all of these components within the assembly and see what that estimated cost is, and the really full visibility into each of these components. If we want to dive deeper into this component where there is that suggested change, we can go ahead and review that part directly and get a better understanding. Okay, is this really going to function? This, this design change here looks okay, but let's take a deeper look at this particular component. We can go in, looks pretty straightforward. There's no design guidance or DFM issues that have been flagged. If there were problems where, it was redesigned and maybe there are holes too close to an edge or bend radii that are too tight, none of that's flagged. It would be if there were some manufacturing issues here. So at this point, we've got a pretty good potential design change here that could save everybody money. Now it's okay, what do we do with that $200,000, right? We're gonna be able to potentially both benefit from that. So assuming that all went through fine, now as the supplier, we can take a look at, the next phase. Okay, we've looking at the manufacturing process. So really trying to get an understanding of what it's going to take to deliver based on these requirements. And here I can take a look at a way to support the manufacturing engineers and give them what they need. So through the simulation, a full understanding of the manufacturing process was analyzed, the time required. And in this case here, looking at capacity requirements. So there's a 3,000 kilonewton, 5,000, and 7,000 kilonewton press required for the progressive die. We can see exactly how many hours required. So 1,200 on the 3,000, 1,150 on the 5,000, and on the 7,000 here, 579 hours. And you can see on the right, the breakdown for each of the components and what they will consume on that machine. So now I can really pull in and fully understand what it's going to take to deliver, make sure I have the capacity. I might have been bidding a package that had some components that I don't even have the manufacturing either capacity or capability to build, and we potentially would need to outsource. We could then work with those sub-suppliers to really understand what their portion of the quote should be, so I don't have to wait for those to be returned. I can analyze that, and then when it does come time to working with them, have the data necessary to support a negotiation. So just wanted to provide a little overview and a glimpse into the solution and how it could be applied to very quickly respond to RFQs simulated based on your factory capabilities, getting results that you can trust because it is based on your manufacturing process, and ultimately enabling collaboration internally and with your customers to really help make better business decisions and improve your position as a supplier with your customers. I want to turn it over to Nick, and based on the demonstration that we just saw in the technology and how it's been applied, listen to Nick in Team Industries and how they apply the technology within their organization to help them be a more strategic supplier to their customers.
Very good. Thank you, Steve. That was an excellent presentation. I really appreciate you highlighting the depth that aPriori, the depth of knowledge and process that aPriori provides. It's not just a simple click a button and get an answer. It's very in-depth. It gives the entire process, and it's something that you can take to the bank, as it were. So we appreciate that. So to get started, hello everybody. Thank you for tuning in. It is a great honor to be able to talk to you all today and explain Team Industries and how we do business, how we're using aPriori software to improve the quoting process and to get you your numbers back faster and more accurately. We entitled the presentation a request for collaboration because we have found that the very best solutions that we're able to provide aren't just an answer. We don't do our best work. You don't get your best solution if you're just asking for an answer. So we'll show you how this works. So to introduce myself, my name is Nick Rowland. I'm a strategic cost estimator for Team Industries. I've been with the company for well, most of my professional career. I started out with them when I was 18 years old. They actually paid for me to go to technical college to be a machinist. So started making chips right out of high school. I worked my way up. I went to Milwaukee to learn how to program CNC machines. I've made transmissions for team for many, many, many years. Worked my way up as a manufacturing engineer, worked my way into quality to program CMM machines, and to make sure that your parts are made to print and that the quality that you require is there. After some time at team, I decided I needed to do big things in my life. So I joined the United States military. I was a communications guy, radio guy. I spent most of my time in the captain's tent, just passing messages back and forth. And it was there where I really realized the power of collaboration and good communication. You can have a team of people who are highly trained, but can't communicate. And even if they have every resource available, you're not going to accomplish your goal. Conversely, you can have a very small team of people who really know their job well and can communicate very well and know each other's needs. And you can do just about anything. So I was shocked and astounded at the power of communication. And I've carried that through my career, knowing that that's probably the most important thing that we can do to be successful. After my time in the military, I came back home, went to college. I have several degrees, one in industrial technologies management. I have a bachelor's degree in cellular and molecular biology, and went so far as to pursue a career and a degree, a PhD in cancer medicine. And when I was ready to come home, I called team back and said, "Hey, I'm ready to come back to northern Minnesota. Do you have a spot for me?" And they happily put me in a position as a designer drafter, and then as a program manager in their engineering department. And I've been there ever since. So when I'm not doing that, I like the outdoors and goofing off. I'm the assistant coach for the high school robotics team. So we do fun things. This is what I love. I've been doing engineering and creating and building all of my life. So I'm very happy to be talking to you about what I love and what I do and what I know and how we can do it better. So a bit about Team Industries. Team specializes in providing drivetrains and manufacturing systems that transmit power quietly and efficiently. We supply and develop chassis components for recreational vehicles, off-road vehicles. We produce over 900,000 drivetrain assemblies annually. Chances are very, very good if you have a four-wheeler or anything in the off-road market, if they're large green machines or large yellow machines. Our parts are in it. Our parts make it go. And our assemblies can be as small as a baseball. Some of them are as big as a suitcase. But we're really, really, really good at making gears and transmitting power and doing it in a way that's cost effective, that will work every time, all the time, and we'll make sure that your companies are successful if you're partnering with us. So some of Team's capabilities, we've got 80 full-time engineers. We've got a full service prototype shop, so we can conceive of a part and we can make it, we can heat treat it, we can design it, we can do it all. We can put it together in a full assembly, build your assembly lines. We are a part of the Ohio Gear Consortium. We consider ourselves to be experts in the gear industry. We've got full testing capabilities. We've got a full test lab, so we can make sure that your products and our products are ready for the field and that will make sure that you are successful. Some of the products that we've made, of course, clutches, transmissions. We have some electronic actuators now. We love what we do. We've been doing it for a very long time. But really, Team's core competency is that we are a solutions provider. We don't just make a part. What we do is we engineer a solution for you that helps you be most successful. And it might not be the thing you started out with or thought you needed to begin with. And that's really the core of this presentation. In order to do that and be successful, Team needs plants, of course. So we've got many manufacturing facilities around the nation. We've got some in northern Minnesota, some in the Carolinas, and some in Mexico. We employ over 1,000 people, and we all work hard to make sure that your products make it out the door on time and with the standards that you need. So let's take a look at the quoting process. right now, today, the landscape of the quoting process looks exactly like this slide. It is a briar patch. And by and large, suppliers and customers are walking through this briar patch blindfolded and barefoot. Just imagine that for a minute. The goal, of course, is to get through this briar patch and have a completed project and a process laid out wherein you won't get stabbed too badly. You can still meet your budget requirements, and you won't realize halfway along the way that you're no longer profitable. The project is in terrible trouble at other deadlines, or you have to figure out how to make up the gap somewhere. It's very frustrating. We hire experts. We call these people estimators, and those estimators provide quotes. The thing is we don't know if those estimators really know the best way through. They know a way through, and they do provide an answer, but we don't know that it's the best answer. It's just the one that they give us. So to combat this, we seek many answers. We seek many quotes from many people, and this costs a lot of money, actually, both in time from the customer's perspective and potential losses if their quotes aren't competitive, and also from the supplier's perspective. They don't know the process all the way through most of the time either. So it puts everybody in a great deal of risk, and so everybody, as Steve pointed out, tends to pad the quote just to protect against these risks. And honestly, the quoting process hasn't changed all that much, and it's kind of astounding now in our digital world. We have digital everything. Our entire lives run on computers, yet our quoting process is still rather archaic and old. We produce paper quotes. We don't typically reference a model live. We don't typically work hand in hand with our customer, knowing exactly what they want based on that 3D model. Instead, we rely on our experts to try to produce a number that we hope is correct. And that's a scary proposition, honestly. And the world is such now, and the competition is so great, that we really cannot accept the risk of not collaborating. We need to know what you need, and we need to be able to deliver for you. So in order to best explain how the quoting process can work in a very efficient way, we've created a fictitious part here. This part is about as simple as it gets. There's a 2.5-inch diameter roller. It's 1 inch thick, and there's a 1/2-inch hole in it. And the reason we created such a simple part is because it's really important to understand the power of collaboration and the ability of the software to do a deep analysis and provide the best cost solution for our customers and for us as a supplier. Because at the end of the day, bringing your product to market is really what's going to make both of us money. If it's wildly expensive, you're not going to get to market, and we're not going to produce your part. So what we did is we created this part, and this was based on a part that was showcased in last year's aPriori user conference. It's used in the ag market, and they provided a price for this part of near $50. So using the software, we costed this out, and I set the annual usage and batch size to a number that produced a $50 starting point. It's, as I said, a simple part. It's made out of 1010 steel, nothing fancy. And so we're starting out at $50. Now put yourself in the mindset of the customer, or of the OEM. We've made this part. We have prototype parts, and now we want to go to production. So we would go to my supplier, and I would say, supplier, what can you do to drive cost out of this part? Because $50 per part is probably a little bit much given its complexity and weight. Now, just about every supplier will happily do a VAVE, value engineering exercise with you. And inevitably, an engineer will say, well, if we reduce complexity of the part, it will save you money. That's normally how it goes. Less machine time, less cycle time equals less money. So let's do that. We take this part. As I said, this part right now is $49.64. So once we reduce complexity of it, when we reduce complexity of this part, see, we took the tree panning out. Now it really is as simple as it possibly can be. It can't be simpler and still work. And in fact, some may argue that it's too simple and looks, well, cheap. And if the assembly costs thousands of dollars, don't know that we want a part that looks cheap. But you see that the cost result of this is only a few cents. We only saved about 30 cents taking the tree panning out of this. And at this point, this is where most customer-supplier relationships begin to break down. From the customer's perspective, I made the part as simple as I possibly could, and you're telling me I only saved 30 cents? That's ridiculous. Why can't it cost me less? Why won't you? I think you're robbing me. And from the supplier's perspective, it costs what it costs. I would love to be able to charge you less, but honestly, volumes are dictating that it is what it is, and there are setup charges. I have to feed my people. I can't decide who I'm not going to pay today. I'm sorry, supplier or customer. I would love to charge you less, but I can't. So we would hope, honestly, at this point, you would call a company like us, where we're able to collaborate with you directly, show you how we're going to drive costs out of this assembly, out of this part, and get you a cost solution that works for you, that is cost effective for the project. So I used aPriori then to cost this part out and made a couple of changes. First of all, you're going to production, so we'll set a batch of 1,000 pieces. And in order to make sure that you're not getting your assembly lines flooded with too many parts, we're going to set a delivery, a batch, or EAU of 1,000 and a batch of 50. The material is still the same, and we want you to get the part that you want. So we put all the extra features, tree panning, and things like that back in. Now, if we look over at our costs, we see that it's dropped down to $4.72. That's a huge savings, a huge savings. We went from $50 to $4.72. But that really isn't the end of the story. Just because you found a price doesn't necessarily mean it's the lowest price. So you would ask us to do further investigation to see if we're globally competitive. So we would continue to do that for you. The next question we would ask you is the volume going to go up? So if it did, we set a volume at 10,000 pieces, annual volume at 10,000 pieces, and batch sizes of 2,500. Well, that drives the cost down to $3.24, which is really a long ways from $50. But the question always comes, can I get this cheaper somewhere else? And we can answer that question. So we run the same part with the same basic setup, 1010 steel, volume batch size 10,000, 2,500 piece lot. And we run this as a forging in Taiwan, because we ran it as a forging in America. And we find that, in fact, it is not cheaper to source this part overseas. We find in Taiwan, you could get this part for $4.43, $3.98 in China, and still the $3.24 in America. And that's rather astounding to a lot of companies, because the idea of sourcing a part that we thought was $50 overseas and now costs $4 sounds like a great deal. But really, and especially in a COVID environment where supply chains are disrupted and people are having a hard time getting the same stuff that they gotten forever due to the virus, staying at home reduces risk, and it reduces the need to put more costs into it in the form of margins. I should also point out too that these are just should costs. There is not margin built into my numbers. And as Steve pointed out, some companies have realized that the last thing to really negotiate on is margin, because everybody who has this software is going to be able to see what the should cost is. They're going to be able to see a clear process, know exactly what goes into it, exactly how much the materials should be, what the labor should be, what the logistics should be. At the end of the day, it really all comes down to risk, and risk gets mitigated by margin. So every part has a unique margin, and margin is really what the negotiating piece is going to be in the future. But we're not done yet. Team has a global sourcing team. We've got, I would say, 10 people who are completely dedicated to finding your parts and finding them at the best cost globally and getting you the right answer. And that might not be in America. So if we do our due diligence, we find that if we find this same forged part that we would have sourced in China or in the United States, we can get it out of Mexico for $1.38. And that's fantastic. That's when people really start to get excited that a sourcing solution for this one is probably a good idea. And companies who work closely and collaborate with their suppliers can stand to do very well. But that isn't the end of the story either. If you really work intently with our engineers and we have a good working relationship, it can be found that a part like this actually can be made more simply and more cost effectively. If we were to bring it to our engineers, they may find that instead of it needing to be 1010 steel, we could do a ductile iron, Oz-tempered ductile iron, 80 grade ductile or something like that, and machine that in Mexico. So we run that analysis and we find that this part is 77 cents, which is fantastic. We went from a $50 part that was the proto part to a full production, full run at 77 cents each. And that can win a project. It can make sure that your projects overall are successful. If you are having a difficult time meeting your budget constraints on other parts that are very complex, perhaps we took enough money out of it to make you successful and make your project come to market. So the total cost delta on this is $48.87. And it looks like this. We started out at $49.64. Through volume increases and design changes, we found that it was not cheaper to source it overseas. We also found that if we change the process and change materials through good engineering and good collaboration between customer and supplier, we can find you a very, very cost-effective part. But if anybody who's run projects knows, the solid cost of a part isn't necessarily the entire story. If you're only going to run a few pieces, as we see in our breakdown here, on a 5-year production run, you're only going to spend $2,482 on your part. Well, that's the best option. If you're not going to make very money, then spend the prototype costs on them, because at the end of the day, your spend is going to be rather small. If you need a mid-level production volume, staying in the United States, North Central USA, is the best option. You're only going to spend $23,600 and you're going to get all the parts that you need, even if the piece part cost is $4.72. But if you're going to go higher volume than that, then definitely investigating ways to make it more cost effective and working with your suppliers is where you're going to save the most money. You can see that you can get this part at 50,000 of them for $38,500. And you would spend many, many, many times that if you were to source it to Taiwan or China. So understanding the whole picture, getting the whole picture because aPriori provides it and because your customer and your supplier are working together to find these numbers together is what's going to make you the most money. And that's what team would like to be able to put out there, that we are a solutions provider. We would love to help you. If it's something that you would want to call us on, we'd be very happy to take a look at what you have and then try to find a solution with you. So to give you an idea of what it took to do this and the further impact and cost savings of aPriori, I started designing this simple part at 10 a.m. And within a matter of hours, I had run over 64 different iterations of costs on them. So the numbers that you see are the boiled down numbers. Actually, every scenario had all of the material types and all the volumes and everything cooked into it. But it only took me a few hours to get that. Now, under normal circumstances, it would take 4 departments 2 to 4 weeks to get any quote back on a single part and a single scenario. If you were to ask any supplier for 64 different variations of a single quote, they would probably quit talking to you. Worse, if you did all that work for them and then you didn't end up using them as a supplier, they'd probably never talk to you again. But the software makes this really simple. And as Steve pointed out and gave the demonstration there, it's very, very fast to get the information, and the bulk costing capabilities are built into the online software. So what I did in a few hours actually is being automated and can be done much, much more quickly. There will still be the requirement for an engineer to look through the data and just make sure everything feels right and looks right. But we are in a new age of quoting, and it's really quoting through collaboration. So if we go back to this part, in the past, we had a briar patch. We didn't know our way through. We didn't know if our suppliers were telling us what's right or wrong. Even if we got 10 quotes from 10 different suppliers, we didn't know if it was the right way. But when we quote using aPriori, we can see the path that we need. We can see the process in depth, step by step, machine by machine, and second by second. So we know before we ask for a quote, the final quote at the end, we'll know what to ask for. We'll know that our supplier is providing good information based on solid processes and solid practices, and that their numbers are right. And then we can decide between each of us what level of risk we're willing to assign to this part. That way we can be profitable together. And we know that at the end of the day, our numbers will fall in line with each other, and we won't be surprised. We won't be stabbed by these buyers. So this is the power of collaboration. This is the new digital world of quoting. So as I said, Team Industries is a solutions provider. So if this interests you, by all means, give us a call. Our information is listed at the end of this presentation.
Great. Thanks, Nick. We're going to turn it over now to Peyton to lead the Q&A session.
Yep, great. Thank you very much to both Steve and Nick for sharing your experiences. Excellent demonstration on how modern digital manufacturing simulation can be leveraged to promote profitability for both suppliers and OEMs. So we'd like to take a couple moments here to respond to some of your questions. This first one's for you, Nick. Do you use aPriori on every new project that team has an opportunity to bid on?
We're getting there, actually. We've had the software now for just short of 2 years, and it was a slow ramp up. We tested it on quite a few smaller projects, but everything that we're running new now, we're working diligently to have aPriori numbers on the parts to know what it should cost, and to aid in collaboration.
Great. And this next question is for you, Steve, more product related. Can the data generated by aPriori be integrated or imported into a quoting system or my quoting system?
Sure. Yep. So absolutely. All the data that's been captured with aPriori is stored in a relational database. There's out-of-the-box reports that could be generated as spreadsheets, or more sophisticated integrations where we can either through a file-based exchange or a direct connection to different systems, move the data that makes sense into the different systems. That's could be a quoting system or other systems. In some cases, bid packages come through and they get stored in a PLM environment for a given customer. We have automation that can pull that directly and process that information. So various options to support integrating the different business systems with the data generated with aPriori.
So, and this is for you, Nick, how do you solicit or request from your suppliers the data? You know, there's some machine labor rates, cycle times, and are they willing, as a follow-up, to provide that data willingly in your experiences?
So how transparent is our quoting, I guess is what you're asking. It really depends on the customer. With some customers, we've been working with them for a very, very, very long time, and we're happy to be very transparent. We found that that's the best way to operate, and we both know that we're going to stay in business because we're choosing to do so in a profitable way for both of us. With new suppliers, it's a mix. I think a person still needs to be careful on how much they're sharing, and that really is the whole point here, is that the deeper relationship we can have with our suppliers, and the more that they would trust our company to provide good, real, and honest numbers that make sure we both will stay in business, is the goal. So right now, I would say it depends. The future, we hope to be open book and very transparent.
Great, thanks. And this next question is somewhat related. So how, what format do you provide aPriori's output, or how do you use the data when you are working with suppliers and customers?
Generally speaking, at this point, we're providing reports. In an ideal world, I would love to sit down with my customer and show them the potential savings on their designs, to be able to work through a design analysis with them, to get as deep as they would want us to work. I think it would be a fantastic relationship builder. It would allow their engineers to integrate with our engineers and just make sure that at the end of the day, everybody really gets what they need.
So thank you all for your participation in today's webinar. As a follow-up to our session, we are offering an exclusive opportunity that can help give you a competitive edge. If you have a recent RFQ that you lost, or won for that matter, we can run a cost analysis on the parts and share feedback to ensure you're submitting the most competitive quote possible. This is a limited time offer available only to participants of this webinar. So if you are interested in this opportunity, please reach out to Andre Niguez, whose contact information is listed on the slide. I also wanted to note now that we have attached 2 documents in the handout section of the GoToWebinar panel. One is the PDF of the presentation that you saw today, and there's also a case study by aPriori customer Susie. If you found this webinar helpful, you should check out our annual conference coming up next month, Cost Insight 2020. This year event is virtual, free of charge, and it's chock full of sessions for cost estimating, sourcing, buying, and supply chain professionals. You can go to our website and see more about Cost Insight Generate 2020. If you have any additional questions, please feel free to reach out to the aPriori team or Nick. All contact information can be found, and email addresses are also listed on the slide. Our webinar is now concluded. Have a great rest of your day.